Alright, so let's quickly look at reflection under waves. That's your optics. So we have reflection of light waves. So what is even reflection? So reflection can simply be defined as the repropagations of light waves when incidented at a particular angle on a plane surface. And basically there are two types of reflection. You have the regular or what we call smooth reflection. Then we have the irregular or diffused or rough reflection. So I use rough in the sense that diffuse reflection or irregular reflection takes place on a rough surface, e.g. the surface of a book, while the regular reflection takes place on a very smooth surface, e.g. the surface of a plane mirror. So in regular reflection, we have it that the angle of incidence is always equals to the angle of reflection. So let's, I don't know, we have a line like this. On this you have what we call your normal n, and this is a plane mirror. On this plane mirror you have the incident ray, and here you have the reflected ray. Let's label this point O, and let's label this A and this B. So between angle A, O and N you have what we call the angle of incidence, and between angle O, B and N you have what we call the angle of reflection, and beside the angle of incidence you have your glancing angle G. Here also you have another angle, glancing angle G. Then we have deviation of light rays. If the light ray deviated, then you can have this point as what? Angle of deviation. So from this now we can just have it that line AO is our incident ray, while line OB is the reflected ray, and line ON is normal. Then beside the normal you have the glancing angle, which is G. They represent glancing angle, and D represents angle of deviation. Angle of deviation. Now take notes. angle of deviation D is, if you look at that, it's a sum of angle on a straight line 180 degrees minus angle of incidence plus angle of reflection. And you must know that angle of incidence I is same thing as angle of reflection from the law of reflection. So we can have it that, okay, deviation could be 180 degree minus I plus I, which will give 180 degrees minus 2I, or we have it as deviation is 180 degrees minus R plus R, which will still give 180 degrees minus 2R. Now note, from that sketch above, we can have what we call the laws of reflection. And what does this law state? You have the first law of reflection, which is, it states that the incident ray, the reflected ray, and the normal at the point of incidence all lies on the same plane. Now the incident ray represents line AO, incident ray, and the normal represent line ON, and the reflected ray represent line OB. Everything lies on the same plane, which is this mirror, is that, and that is what we call law of reflection. The first law of reflection, the incident ray, the reflected ray, and the normal at the point of incidence all lies on the same plane. Now that is first law. Then the second law of reflection is angle of incidence is equals to angle of reflection. Angle of incidence is equals to angle of reflection. Now remember what I said about the regular and the irregular reflection. Regular reflection is a kind of reflection that takes place on a smooth surface, e.g. the surface of a mirror. So in regular reflection, you can have something like this. Here now is a plain straight surface. So at this point, you have your normal fixed here, and then you have the angle of incidence here, and you have the angle of reflection here. So for a plane surface which is smooth, angle of incidence is equals to angle of reflection, and that is for a smooth surface which is like a plane mirror. Now on the other hand, you can have the irregular or diffuse reflection. This takes place on a rough surface, let's say the surface of a book, something like this. So you have different angle. A ray of light comes in like this, another ray of light comes in like this, another ray of light comes in at this point. Now their angle of reflection always varies. This can go out this way, while this can go this way, and this can even go this way. So angle of incidence and angle of reflection are not always the same in irregular diffuse reflection. The irregular or diffuse reflection, angle of incidence is not always same as angle of reflection. This is going out. So here it can happen on, let's say, surface of a book, why this can happen on, let's say, plane mirror. So you can have something like this, different plane mirror. You can see that the surface is plane, this is coming in like this, this is coming in like this. They are going to go out at the same angle, because it's a plane surface. So angle of incidence for a plane mirror is also equals to angle of reflection, and that is what we call the law of reflection. So from this sketch, we can quickly come up with the two laws of reflection. That, okay, the first one, the angle of incidence is equals to the angle of reflection. That is second law of reflection. Then you can bring out the first one, the angle of incidence, the angle of reflection, and the normal at the point of incidence, this is the point of incidence, all lies on the same plane. That is it, all are on the same plane, while angle of incidence is equal to angle of reflection stands for the second law of reflection. Take note of that. So it's possible to have examples like you can have something like, okay, one, a ray of light strikes a plane mirror at a glancing angle of 55 degrees. Calculate the angle between the incident and reflected rays. So if you look at this now, all I need to bring out from here is, okay, you have what? Glancing angle given to you. So you have a plane mirror first. So this is the normal on the plane mirror, and this is the plane surface of a mirror. So you have the incident ray given here, and this will be the reflected ray given here. Now you were told that a ray of light strikes a plane mirror at a glancing angle. Glancing angle is the angle between what? The plane mirror and the angle of incidence. So glancing angle of 55 degrees. This is 55 degrees. This other part also gives 55 degrees. So now calculate the angle between the incident and the reflected. This is incident, and this part is what? Reflected. So calculate the angle between them. So I can call all the angle between them theta. So if you look at this is looking like a statement of sum of angle on a straight line. So I can just assume that, okay, sum of angles on a straight line equals what? 180 degrees. So therefore all I need to do is addition of all the angles on this part should be equals to 180 degrees. So what are the angles? We have 55 degrees plus another 55 degrees plus the angle between the incident and the reflected, which is now theta. Everything equals to what? 180 degrees. So 55 plus 55 will give me 110 degrees plus theta equals to 180 degrees. So collect the like times theta is going to be what? 180 degrees minus 110 degrees, and that will give me 70 degrees. So the angle between the incident and the reflected ray is 70 degrees. So let's pick another example here. You have it that you are given a sketch. This time around, a sketch. This is one plane mirror, and you are given another plane mirror. So you have this. This part is given as 40 degrees. This is reflected, and this is coming out. This part is called N, this is called Q, and this point is called P, while we have this point as O, and this is 90. The two mirrors are inclined, so you have the question that two mirrors of the same length are arranged as shown in the diagram above. Now the question is, calculate the emergent rays that has been deviated through the mirrors. So now all we need here is emergent ray that has been deviated through the mirrors. So I can bring this that, okay, you can have that mirror, looks like this. You have the first mirror like this, sorry, so I have the first mirror straight, this is it. Then I have the second mirror, this, which is this. Then the angle of incidence of this first mirror is at 40 degrees, and it is reflected this way and deviated this way. Okay, so incidence, reflected, then reflected. So at this point, if you look at all this angle here, all this angle here is like 180, so deviation will take place at this point, right? That is angle of deviation. So we call this first deviation, this angle here, D1. Then at this point, another deviation will take place, which is like this. We call that angle here also D2. So all I need to do is, if I trace out this part to bring out normal, if this place is 40, everything here is this 90 degrees. So 40 minus 90 gives this part to be what? 50 degrees, right? Aha. So 50 is standing as the angle of incidence. So angle of incidence is always equals to what? Angle of reflection. So this part also becomes 50 degrees. So angle of reflection is 50 degrees. So here also you have the deviation again to be 40 degrees. That is 50 minus 90, also 40. So glancing angle there is 40 degrees. Come back to this place. If this is 40, if you trace out this part also, if this part is 40, that shows that this part is 40 degree. Alternate angles are equal, which is now incident is 40 and incident is also what? 40 here, 40 degrees. So this part is going to be what? 50 degrees, because 40 plus 50 gives 90. So the glancing angle there is 50 degrees. So all I need is, if I want to calculate deviation 1, D1, the first deviation is going to be what? 180 degrees minus angle of incidence plus angle of reflection. So D1 is going to be 180 degrees minus angle of incidence here is angle of incidence and angle of reflection, they are the same, so you are going to have what, 50 degrees plus another 50 degrees. That means you have 180 degrees minus what, 100 degrees. That means D1 is going to be 80 degrees Celsius. So I need D2 also, deviation at the point 2, which is still 180 degree minus incident at that point plus reflection again, which is D2 will be 180 degrees minus incident at that point is 40 and reflection is also 40. So 40 plus 40, this is it, incident here, 40 and 40. So that means you are going to be left with 180 degrees minus 40 plus 40 is 80. So D2 is going to be what, 100 degrees. Therefore deviation, which is the deviation through the mirror, is going to be what, your D1 plus D2, and that will give me D1 is 80 plus 100. So deviation is going to be 180 degrees, and that settles that again.